Hello guys, and welcome back to the channel. So in the previous video we started working on clean architecture and how to implement it by building a to-do app. And if you haven't watched that video, I recommend you do so. In today's video I'll go through what we did in the last video at a fast rate. So what we basically did was in our features directory we created a feature which is the to-do feature, which means that our app is really simple. It just has a single feature, that's the to-do feature. And an example of a feature that an app can have is an authentication feature, a cards feature, transaction feature. So anything that's deemed as a feature of a particular app, which is different from crowd operations, right? So let's say if you are building a chat app and the chat system is the feature, but the ability to send message, receive messages can be considered as part of the chat feature, which is not actually a feature on its own. So that separates a feature from what we call a use case. So in the features directory we have our to-do feature, and ideally every feature is going to contain 3 subdirectories, right? It's not always the case, but in most cases, because if the feature has some kind of UI associated with it, that is going to be in the presentation of our feature. Then the domain is what is going to contain our core business logic for that feature. So if you are making any logic, right, it's not going to be in your UI, but it's going to be your domain. Now our data section is anything related to data, so database, local database, like you are saving a chat locally, or you are saving an item to a cart locally on the person's device, or even if you are communicating with Firebase, any database you are working with, those functionalities are going to be in the data layer, right? So that was what we basically did in the last video, and we created a model for our to do, and also created a repository that's going to define the functions or the methods this feature has, right? So on today's video, let me pause and check. Okay, so we define some feature that's adding a to-do, editing, deleting, and then getting all our to-dos, right? And as you can see, they are just type definition. So adding a to-do, we are just returning the to-do we added. Editing, we are returning it. Deleting, we are returning it. And the type of these methods are future, right? So it's returned, it's a future, which is an asynchronous methods. Now in our data layer, we have another folders. We have folders in that, which is the database and then the repositories, right? And within the repository we have something called an implementation of the to-do repository we created. So this is where we actually write the logic for the repository, right? So we defined the contract here, and this is where we are going to implement our contract. Now in order to implement this, we need to get access to our database, right? Because over here, this is where we'll be calling our database and adding the to do to it. And as I said in the previous video, we'll be using Firebase for this. So just go to a terminal, and if you have Flutter Fire configured, it's going to be very easy. If you don't have it set up, I recommend you watch my previous videos on setting up and Flutter. So I'm going to type Flutter Fire configure. Okay, so this has brought me a list of all the projects I have on Firestore, and I'm going to create a new project. I have to enter a project ID. Make sure that this project ID is very unique, or you would have to create a project from the Firebase console. So I'm going to type to do _ dash clean dash architecture dash 1 2 3 4 5, right? I'm somehow sure this will be unique, and so this is actually unique, and it's creating this project on my Firebase console. So I'm going to configure Firebase for this particular project, and I'm just going to go with Android. So I'll select Android, Yeah, I'm going to accept this, and that's all. So I've connected this Flutter app to Firebase, and we can now close the terminal. Now let's configure Firebase. So let's go to our main file, main.dat, and change the main function to an async function. And then first make sure that we have our binding set. So you can do that with this Flutter binding that ensure initialize, and then we can now call Firebase. So do Firebase, but then realize we don't have Firebase. So let's go to our aspect.yml file, and under the dependency section, let's add Firebase core Firebase or Cloud Firestore. So Cloud Firestore, and then save the aspect file. Right. So when you save it, it's going to run a Flutter target, and after that, you should have access to Firebase in this project. Okay, so now we have added Firebase to our project, and we can go back to our main.dat file and type in the Firebase dot initialize app, right? And we have to import Firebase. Right, then we can pass now options. So when you use the Flutter Fire CLI, you get this options parameter you can pass. So options, and let's pass in default Firebase options dot current platform. Right, so there is it for Firebase, and this is how we set up Firebase in our app. Now I'm back to the TODO repository implementation. You would have to call our database and pass in the TODO we have here, right? So in order to do that, we don't want to have our Firebase or our database logic coupled together with the TODO repository, right? So we want to have it separate from our actual logic. So it's just like the same logic, but we want it to be separated in a different layer. So let's go back to our data layer, and within the database directory, we can create a file called TODO remote database .dat, and this is where we are going to write all our database logic, right? So let's first define what methods we can call on our database, or what operations we can perform on our database, just like we defined in the TODO repository what type of operations we can perform on the TODO feature. So we are going to start with an abstract class and call it TODO remote database, right? And this will define all the methods we want to perform on our database. So the first one is the ability to add something to a database, right? And what we are going to add is a TODO, and we are going to return that TODO. So a future TODO, and the method name is just going to be add, which takes in a TODO like this. We first have to import this TODO. So I'm going to import the TODO, and it's just going to be similar to what we had previously, right? So I'm going to the TODO repository, then I'll copy all of this, and then come and paste it here. Right, so it's basically the same thing, And this is not the case for all projects, right? This is just per our use case. The database operations are the same as what we are doing, because it's like the whole feature is communicating directly to the database, and it's not compulsory to name the method the same as the repository. You can just name it anything, just as you call it when we are interacting with that particular implementation. So if I'm adding an item, my database, the database method that adds the item to my database can be called add to do item. But then the actual repository, right, which defines the adding of item, can just be called add, right? So we can, for demonstration purpose, I'm not going to use the same name. I can just call this add to do, right? So add to do, edit to do, delete to do, and then instead of get all here, I'm going to name it list to do, something like this, and then I'll save. So now this defines the operations we can perform on our database. Now let's write out the actual function for this implementation. So something like the implementation of this abstract class, and just like we did for the to do repository, this is going to be the same thing. So we are going to have a class called to do remote remote database implementation, which implements our to do remote database, right? And now we have to create our missing overrides, and all these functions must be asynchronous because the return type is a future, right? So just add the async yourself. And now when we want to add a to do, this is where we actually write the Firebase logic. So we are having a to do here, and what we want to do is we want to call Firebase Firestore dot instance. Right, this is our database, and we want to access a particular collection which is called to do's, right? So we are creating this collection if it does not exist on the first time we run this function, and I want to add some data to it. So we call the add method on it, and this expecting a map, right, of string and dynamic. Meanwhile, our to do is a class, so we should have a way of converting this class to a map of string and dynamic, and there is a much easier way to do it. So back to the to do entity, instead of just having the class like this, we can add a method that does this conversion for us, and I'm going to use a generator. So you just have to install the data class generator extension, and now I'm going to generate JSON serialization. So when I tap on this, realize I get this methods added to my class, and the new methods are to map, from map to JSON, and then from JSON, and we'll be using the to map and then from map. So back in our remote database, we want to convert this to do that we have over here to map, right? So we can do it to do dot to map, and this will automatically convert our to do to a map, right? And since this is an asynchronous operation, we can await it. And then we have to return the to do we added per our function definition. So I'm going to return the to do, and this the database logic, and as you can see, it is not coupled together with our business logic, right? So there will be a place in our UI or in our app where we would want to add to do to a database, and we just have to call this method and passing it to do without repeating ourselves, right? And if there is any bug in our system, it's much easier to find and fix. Also, when it comes to deleting a to-do, just like we did here, we can do exact same thing. I'm going to await Firebase Firestore dot instance dot collection the to-do, and they want to access a to-do which has which is a document in the collection based on the ID of this to-do, and then call the delete on it. And later on we can return the to-do we deleted. So we can return this to-do like this. But then in this case, when we use the add method from Firebase, it's going to generate a unique ID, right, which is not based on what we have for the to-do, right? So as you can see, when we are adding the to-do, we're not passing any ID to it, so this operation will fail. In order to fix this, we have to change our add method to a different one, and this time around we're going to access a particular document, right? So a document, and then we are going to pass in our ID, right? And now within this document we can set the data, right? So set is another way of adding data to Firebase, right? But with that one you provide your own ID, right? And that's the ID coming from our to do. And now we can convert our to do to map, so call it to map, and now we can add a to do with our own ID, and based on that ID we can delete it, right? So when we get to the edit to do, you can guess it's going to be a similar situation. So we're going to await Firebase Firestore instance dot collection, and then our to-dos collection dot doc, which is our to-do dot id dot update, right? And we can pass in our data, which is to do dot to map. And when we are listing the to-dos, we're going to have a variable called to-dos data, which is going to be Firebase Firestore dot instance dot collection. Then we pass in the name of our collection to do's, and you can always refactor this name somewhere in your code, so I don't have to be repeating them manually, right? And then we want to call the get method on this collection. So this will return us all the data in this collection, and now we can return our to-dos data so we have to await this. I forgot to await here. So we can have our to-do.docs, which is the document itself, and then we can map through, right? So for each document we want to return a to-do, right? So we are going to return to-do dot from map, and then our map is going to be this particular to-do, which is our E, represented by our E here. We can replace this with item. So for each item we want to have item here, right? And then we have to convert everything to a list, because a map doesn't return a list. And this item, it's not just the item that I want, but I want the data from the item, right? So this will return us a list of to do. So we have a document, right, which is a list of query snapshot documents containing a map of string and dynamic, and we are mapping over each document, right? So we are calling it item in this case, and we know that todo.forMap is a method we created that returns a to-do class based on a map value, and our map in this case is our item.data, right? So item.data is going to give us a map of string and dynamic, and when we use the map method on anything, it doesn't return as a list, it returns as something we call iterable. So in order to get a list out of it, we call the toList method, and this is going to return as a to-do, right? And in our edit to-do function, we have to return our to-do here to get rid of the errors, right? So this is how our remote database is going to look like, and it is not coupled together with our implementation. So then how do we actually add a to-do? So back in the to-do repository implementation, we have to get access to our remote database, right? So I'm going to create something like a variable, right? And that is going to represent our to-do remote database. So the type must be our to-do remote database, right? And I'm going to call it remote database, and I have to generate a constructor for this, right? So in the add to do method, all that we have to do is call the remote database dot add to do, right? So within our repository, what you normally be doing is you'll be calling your databases, right? You'll be doing a lot of things in this repository, except when you have to. But in most cases, in most CRUD apps, you just be calling your database, your remote database, local database from your repositories. That's the main thing you'll be doing. So I'm going to create a variable called results, and I'm going to assign it to remote database dot add to do, right? And this expected to do, which we are passing from this side, and we have to remove the true unimplemented error and then return the results of this, right? And we know that the results is a feature of to do, right? So when we add this, we first have to await, right? And our results is a to do. Now what if we get an error whilst adding a to do, right? Maybe Firebase, we don't have permissions, like rules have not been set and a whole lot. So it means we have to wrap this in a try catch, right, to handle errors for all the operations. And you realize in the database layer, that's in the to do remote database, we're not doing any try catch work. That's because all the error handling when it comes to performing operational features, right, the ones involving database and other things, will be handled in a try catch only in one part of our whole app or our whole layer, right? So within the domain, presentation, and then data, right, we are only going to handle errors in your implementation, right? So in your repository implementation, that's where you'll be handling errors using try catch. So in your UI, you won't be writing try catch there because you are well assured of which value you are getting. Now adding a to do to a database can either result in a to do or a failure, but in this case we said this method should return as a to do, right? And we are returning the results, which is expected to be a to do. But what if we get an error here? It means this is not going to return as a to do but something else, and this whole function will break. So there must be a way to return either a failure or a to do, right? And that's what we'll be looking at in the next video. So if you like this video, hit the subscribe button, like it as well, and let me know what you think in the comment section, and I'll see you in the next one. Bye.